Hello and welcome back to Sydney Summit here on the Twitch live stream. Joining me today is Dr. Kazi Zaman. He's from EA. If you watched the keynote this morning, you would have seen him talking about reinforcement learning. Welcome to the show, Dr. Kazi.
Great to be here.
And my co-host today?
Dr. Pete Stansky, guys. I run a solution architecture function for Australia and New Zealand, and I'm actually a confessed ex-game developer.
Nice. And
excellent. Kurosh, I'm the solution architect based in Sydney, focusing on machine learning and AI.
Okay, I'm Sean Ray, your host. I do everything developer and everything Twitch. Really what we want to dive into today in this segment is the reinforcement learning in our EA games, which Dr. Karsman works for, and what they're doing. So over to you, Dr. Karsman. Can you tell us a little bit about your role and what you're doing there?
Sure. So I'm the VP of Engineering with a special focus on data and AI. So when you think about playing EA games, you're generating a lot of data. That data needs to be collected, analyzed to make players' lives better so that we can tune the games. And so extracting value from those petabytes of data, in a nutshell, that's my job.
Okay.
There's a lot of data generated by a gamer, right? I mean, there's a lot of writes and less reads. What sort of volumes are we talking about?
Yeah.
I mean, there's a lot to deal with.
I mean, lots of petabytes. And as I think I mentioned in the keynote, the volume's are also very spiky. So if you think about a day like Christmas when everyone on the planet opens their new presents and starts playing the game, you have enormous spikes. And you require a lot of compute and a lot of storage to be able to deal with that. So lots of data is being generated. We're basically consuming from a fire hose of data all the time. EA has games, mobile games, console games, PC games, and lots of them are generating a lot of data. It's a lot of data to play with.
I'm a gamer myself, and I played a lot of morgues, and especially when you interact online. And one of the frustrating things as a player is dealing with robots and other people like in those simulated environments. Is that something that like EA is looking at? Is that something you're using in the machine learning space? To try and combat those types of problems?
Yeah, so I think there are two problems over there. You referred to bots, and in many cases, bots are being used to diminish people's experience because in many cases, a bot may just come in, drop off, and that person's part of your team or your squad. It's not a lot of fun. Mm-hmm. So I think as I talked about in the keynote today, we're using data and AI to figure out who bots are, and if bots are indulging in activity which isn't player-friendly, take necessary action. But I think another more interesting thing to look at is bots can, if we use AI the right way, and we can use it to make your experience even more pleasurable. Imagine there was an AI who was continuously learning within the game, and you were encountering an NPC.
Sure.
The NPC knew who you were.
Exactly.
And reminded what you did the last time you had an encounter with them. That might be a lot of fun.
And you mentioned that you can do some really clever things, like the player gets into a multiplayer battle and they get shot really early. You can also recommend or play a video for them, help them upskill and level up, I guess, on experience points or other things to get better at the gaming.
Yes, absolutely.
And
so I think
on the same note, obviously you have a lot of use cases for machine learning and AI in your basically your department. One of the things, since most of our audience are developers, one of the things that caught my attention was how you're using reinforcement learning to detect bugs, basically doing testing before going live, as opposed to getting human agents to run those testing for you. Can you tell us more about that?
I can do a little bit about that, but again, I think I do want to mention that, as in the keynote, we're using this AI to augment the lives. There are certain test cases for which humans still have a role to play in this. I want to be very clear about that.
Absolutely.
But I think what's interesting is that what we do with using AI, we use AI not just to detect bugs within the game. You can have a single AI agent which plays the game and detect bugs. But some of the use cases I talked about, like what's happening in the economy, how are people progressing? Different players model players in the real world. Some people are really good and move quickly, others don't. So what you actually have to see is what are the distribution of all these agents, what are the interactions between the agents are. And these are basically really, really hard, still open AI problems which my team is focused on.
So this is the concept of the agent-based simulation. They used to use it a lot in economics. I think World Banks and other places used it. And it's really cool to see that in gaming because it's such a complex environment.
Yes.
Some of the games that you see have thousands of players interacting, selling stuff, trading stuff. It would be impossible for a human to go in and recreate that type of thing.
Exactly.
I want to do a shout out just from the chat. We have someone watching from the US, Ed Manila. So he's watching from North Virginia. So thanks for watching in your time zone. It's very late for you. So we're very thankful for you tuning in. So I want to cover a little bit, I guess, about Amazon and AI as well. Kurush, you're studying in this area. how do you think Amazon interacts, and what's your view, I guess, Dr. Kazi, on Amazon trying to get machine learning into the hands of each developer, which is really my job and my team's job?
Yeah, so I think that as we think about machine learning and AI, it's one of the transformational technologies of the future. I mean, when we look 5 to 10 years ahead, it's going to be something which is impacting everyone's lives. So I think it's really important as a developer that you know more about it, and the fact that Amazon is making these tools available for everyone is great. But I think it's also equally important, if you're a developer, that you should know your domain very well.
Mm-hmm. Yeah.
Tools are all very well, but you need to know, what am I using the tool for doing? What we should know at its heart, AI is an optimization problem. You're optimizing for something. Mm-hmm. You need to know your business really well and what you're trying to do. So I think that Amazon's known for its customer obsession. I would say is Amazon developers should also know the domain and know their customer. And that's really key for moving forward.
That's a very, very important point. Having that domain knowledge helps to build that context around what you're delivering as this new wave of machine learning and AI coming into the dev community, basically. Absolutely. Speaking on that, in general, data science and machine learning revolves around a lot of research and experimentation and confirming hypotheses or refuting hypotheses. On the other hand, engineering is all about well-defined inputs, well-defined process, and well-defined outputs. And there's not a lot of guesswork or science work involved in engineering compared to science. So can you tell us how did you marry these two groups of people in your team? How they are working side by side together?
So I think a couple of points over there. I think what's really important to be successful in life is that you actually do need a little bit of both. I think that simply because you're an engineer doesn't mean you shouldn't be taking a scientific outlook on things.
Excellent.
You should always be having a hypothesis, testing the hypothesis, and if the hypothesis, whichever way it falls, you should be a Bayesian and be willing to update your priors based on what you see. And I think the Amazon cloud is actually a great example of that. In engineering, the kind of engineering you would do if you're on-prem on a data center is different from the cloud. The assumptions are different. So even if you're an engineer, you need to have a scientific update because the world is changing, and based on the changing world, you need to approach things differently. So I think that when you hire people, and when I hire people for my team, intellectual curiosity, the ability to learn new things, and the ability to play different roles and wear many hats is something which I look for. And no matter what you're doing, we always rotate you through the various functions of the team so that you have a very good idea of what everyone in the team is doing.
Sure. Interesting.
So I think that's really important for
Actually, that was
successful.
one of my questions. What does it take to be a developer in your team? You answered it.
Yeah.
So how about the actual non-technical skills? Because obviously when you talk about AI and ML, and there are human factors, right?
Yes.
Human aspects that don't quite fit into a box of necessarily engineering. But there's also a whole bunch of soft skills. So what kind of a balance in your team, for example? Where does the needle go to be highly engineered, data scientists, soft skills? How do you guys look at that? How do you look at yourself?
Well, first of all, they don't let people in with blue bow ties in the interview. Step
Well, a
one.
big call out to Okta. Thank you for letting me having a tie. Thanks, guys.
Yeah, so I think again, the key is over here is, as I mentioned earlier, you need to understand your customer.
Yeah.
And without customer empathy, you're not be able to really get anywhere. So I think that regardless of whether it's AI, as I mentioned earlier, you're using AI to optimize something. So in the keynote, I talked about, okay, how are you going to make an artist's life better using deep learning?
Yeah.
Yeah.
So until you understand what the artist is doing, until you shadow the artist for days, until you know where the artist's pain point is, you're not even going to know what the right problem to solve is.
So true, yeah.
So I think that's really, really key to success is you can't just say, I'm going to use services in a box and do magic. Without understanding what you're trying to do in the customer use case and the customer pain point,
Yeah.
you're not going to get there.
Because in my gaming career, I used to always look at gaming as it's engineering, but it's also art.
Exactly.
Right? It's about creativity,
Exactly.
allowing creatives to actually be able to expose new ideas and
Yes.
be characters, playability, game theory, a whole bunch of those things. And now you're adding, AI and ML on top of that. I think it's a fascinating space that we're living in at the moment.
Especially
Really
like the profile types, right? So I play different games. Like there's speedrunners who just just try and go through as quickly as possible. I'm a completionist, so I like to get 100% of all achievements on the way through. You know, if I get that quest bug or that thing 1,000 hours in, I just, you know,
get that extra last final coin, right?
Yeah, exactly.
Yeah,
and you know, it's impossible to test for, but it's also fascinating for you to basically build these virtual worlds, do this agent-based simulation where you can find that. And where do you think that's going to go to? You know, you guys have published papers in EA, your team has, you've been working on this for a little while. What do you think is kind of next? What are you excited about working on next in that field?
So I think we've basically just begun. When you think about what a reinforcement learning based agent could do, I think we're at the beginning of our journey. We may have worked on a while, but these are by no means solved problems. I think that how do multiple agents interact, what happens with the economy, there's a lot of room in which we can keep doing better, and I think the problems I've talked about, I think they're fertile ground for work for at least the next couple of years. Of course, I think what's really interesting is the space itself has changed so rapidly. When we look at what deep learning, when AWS was founded in 2006, there was no deep learning.
Yeah.
But there still were recommendations on the Amazon homepage.
Totally. Totally.
So I think you have to find the balance of the right tool for the right job. But I think that basically empowering people to be more creative and how AI can help, I think we're just at the beginning of that journey.
I think
But still day one, as we
Still
said.
day
Amazon.
one.
Still day one.
Still day one.
So I guess in the future, with the help of AI, with the help of new technologies that might not be here today, we're going to see the line between the game player and the game creator blurred more and more. Is that a correct assumption?
Yeah, so I think as the tools become more open and we look at games of the future, I think people do want to create games and modify games. There's a huge community of gamers who want to mod.
Yeah.
So what are the tools which we can make available to them? And they're not going to be C++ programmers. So if you think about it, AI would be a critical role in allowing anybody to build the world of their dreams.
Can you visualize it for us?
I think I just did.
That's a tough ask.
So you mentioned about Yosemite, for example.
Yes.
You are creating a new map, you get the LiDAR data out of Yosemite, you get the aerial imagery out of Yosemite, and basically you create Yosemite and then you can play in it, right?
Yes, exactly. You can use satellite data. Imagine that. You can take a picture, you can take your own selfie and you can augment it and imagine that you are over there as a character. I think the possibilities are endless.
Fantastic.
So in your keynote, you also talked about detecting bad actors.
Yes.
Right, because when you play games, people don't always necessarily do the right thing. Now, tell us a little bit more about that, because that's a fascinating element of detecting things that shouldn't be happening in games.
Yeah, so I think again, as I mentioned in the keynote briefly, there are lots of people who do it for different reasons.
Yeah.
So there are rich virtual economies. Anytime there's an economy, there are people trying to do bad things. So when you look at this persona, you want to ensure that they're not doing anything which detracts from the fun of the game in a virtual economy or market. If somebody's cornering the market or there's an artificial flow of money being printed by someone, that's not good. Now the good news is data allows you to detect what exactly is going on, and we can use that to figure out what's going on. There's other kinds of bad actors, like for example, you may want to climb the top of the leaderboard. In that case, what you would do is you may be hacking the client, for example, and doing something over there. Now that can be detected by checking the footprint on your systems and having systems over there to check what's going on and that kind of thing. So I think depending on the vector, there are lots of various classes of service. I think what's interesting is that you have to take a variety of approaches to detect the different kinds and different families of bad actors.
I was talking to Sunil Mailis, so he's the person who's running the Deep Racer upstairs for us. And one of the things we were talking about is there is actually a theoretical limit of how fast that car can eventually go based on engineering, the way the track is. And so we kind of have a natural boundary that we have calculated, which has been wrong twice, but still. So I guess in games as well, there must be things that for instance, there's no way you should be able to generate money that quickly, or you can't get to the end that quickly. And so just by doing that as well, you have like some kind of natural place barriers of that person must be outside of the bounds of normal.
So if you're teleporting from one place to another, or you're going faster than the speed of sound or light, we know that you're doing something which is should not be possible.
That's right.
Well, it's a common exploit, right? Because a lot of people try to hack the client that talks to the server backend and go, you know what, if I can just tweak this protocol or send a raw packet, that's the wrong packet, or decompile the code, I can teleport myself all over the game player.
Yeah. Well, I guess when the games give you the capability to actually create, we're going to have a lot of those talents instead of hacking the system, trying to create new things or new mods.
Yes, absolutely.
Yeah. I also think, that thing about game creator, game person blurring. So look, I want to get to the point where I can basically build my own agent that's kind of running and I just hands off it inside the game. Like that's kind of that agent-based simulation where I'm actually building an agent and trying to figure out if I can navigate some of those complex worlds. So opening that up, I guess, and seeing that, I suspect we'll see some of that in the future. You see things like bots being built for games and stuff by third parties, and they eventually get hired by the studios. So that's like a very exciting avenue, I think, that we'll go down, where people will actually build that kind of agent models themselves.
Absolutely.
Absolutely. Exactly.
All right, we're at time. So thank you for joining us. Thank you for joining us, Dr. Kazi, Dr. Pete. Karush and I haven't quite got our doctorate yet, but we're working on it. We're up here, we're learning about AI.
I have probably another 12 years to go, but I'll get there.
That's right. I'll do
Maybe
it before
sooner
I
than you
retire.
think.
All right. Thank you very much,
Thank you.
Sydney. Thank you very much, Dr. Kazi. I hope we provided you some good insight into reinforcement learning, and we'll see you next time.
Thank you.